So here's a 3-loop mesh analysis example that we're going to look at. And in this case, they're asking us to solve for Ix, which is this current right here. And what that'll end up being is one of the mesh currents, the value of that. So let's see how we would go about doing this one. So first, let's define some mesh currents. So we'll call this one I1. And then we'll call this one I2. And then finally this one, we'll call this I3. Let me clean this up a little bit. And this one here will be I3. And let's define our mesh equations. So the first one we want to look at will be the one associated with I1. And so in this case, we see that we have these resistors that I1 goes through. So that's the total resistance. So we can add those up, and that's going to be 9. So we can write that then as 9 I1. But then we also notice that this resistor has the I2 going through it, 2, and it's working against us. So then that'll be a minus 3 I2. And then finally, for this loop, we see this resistor has I3 going through it, and that's working against us as well. So then that's going to be a minus 2 I3. And then we see we have a voltage source right here, and we hit the plus sign first. So let's highlight this differently. So we have this voltage source here, and we hit the plus sign first, going in the direction of I1. So therefore, that's going to be plus 12. And then that's everything involved with that loop. So that being the case, we should be able to set that one equal to 0. So now let's move on to our loop associated with I2, the blue. And here we see we have these resistors that I2 goes through in blue. So that's 4, 5, 6, 7, 8, 9. So we can write that then as 9 I2. But we already know the 3 ohm resistor where it shows the red here. So it's working against us, so that's going to be minus 3 I1. And like we had before, I3 also goes through this 2 ohm resistor, and it's working against us, so that's going to be minus 2 I3. In this case, we have the same voltage source, but this time when we encounter it, we hit the negative first, so it's going to be a minus 12. And so that's everything that contributes in that loop. So then we should be able to set that one equal to 0. And then finally, we have our loop associated with I3. And so here we already see the 2 ohm resistor, so now we have this 5 ohm as well. And so we can write that then as 5, 6, 7, 8, 9 I3. But we see that 1 2 ohm is associated with I1 in the wrong direction, so that's going to be 2 I1. And then the other one's associated with I2, so it's going to be 2 I2. And so that takes all of those into account. There's no voltage sources that we have to account for. So in that case, that's going to be equal to 0. So now we can rewrite these in a more usable fashion. So it's going to be 9 I1 minus 3 I2 minus 2 I3. That's going to be equal to minus 12. This one, if we rewrite it, it's going to be minus 3 I1 plus 9 I2 minus minus 2I3. That's going to be equal to positive 12. And then finally, for the third mesh, we will have minus 2I1 minus 2I2 plus 9I3. That's going to equal to 0. So now we have our three equations, three unknowns. Several different ways you could solve this. Again, it's a linear algebra problem now. But as you do that and you solve for them, then I1, which is also IX, is what we're looking for, you should come up with a value of minus 1.0 amps. Again, that's from solving this system of equations right here.